Okay, section 2 is how the earth was formed. And so tomorrow you're going to watch a video that's going to kind of explain this a little bit better in a lot more detail too, because it's really important to understand how our earth formed in order for us to understand how life came. You have to remember there are hundreds of solar systems and tons of galaxies, and we are just one planet, and we are lucky enough to be the three bears. We weren't too hot, too cold, we were just right, and so we were able to produce life. And so we need to understand why we're kind of there for that. And so one of the things that we need to understand is that our planet started quite a long time ago. About 14 billion years ago, atoms of hydrogen and helium were starting to be produced in stars. And about 4.5 billion years ago, a nearby star exploded, sending shockwaves through a cloud of dust, increasing its spin, and basically it created our sun. When our sun started to be created, then we could actually start to see the production of a planet. And basically that's because when our star formed, it was able to create gravity. And so gravity will then spin stuff like water in a bucket, and it's going to create that water will cling together, just like those dust particles will cling together. And they start moving fast enough, they can make a planet. Okay, so this is a theory called the Big Bang Theory. And basically in the Big Bang Theory, not the TV show, but the Big Bang, we had this huge explosion, and it sent shockwaves through the entire universe. Now, this again is speculation. We don't know exactly how the planet started, but within minutes, stars started to form and fuse hydrogen into helium. Basically what happens is hydrogen, or your single atom, is moving so fast, when it smacks another hydrogen, it doubles the nuclei. Two helium will smack into each other, doubling the nuclei. And so basically you get bigger and bigger atoms. However, as you get bigger and bigger atoms, your star is actually dying because it's running out of energy. Hydrogen is what does fuel our stars. But the Big Bang basically says kind of how our universe started. And it, again, is speculation. And so basically what we know is that once we get gravity going, or a star going, it will start to, depending on how big it is, we're pretty actually lucky we have a single star. Most solar systems are binary. We have two stars, we only have one. And so basically it's going to start spinning all the material around it, and they'll start to rotate or form into planets. And after millions of years, we're going to start to see, in billions of years, we're going to start to see those planets align and follow a set pattern. And so we'll only get so far from the sun until our sun expands or dies and hits its next stage of life. And basically we're going to lose everything that we have. And so I did say tomorrow we are going to watch a video talking about how our planet was made, specifically for Earth, because it's kind of important that we do know how Earth was made. One of the things that we need to know about our planet, sorry I went to the next slide too soon, is that we have this really great thing called an atmosphere. Our atmosphere actually protects us more than we ever dreamed possible. Saturn has a really thick atmosphere, but it doesn't have the wonderful hard surface that we have. Venus, on the other hand, has almost no atmosphere, but has the hard surface that we have. And so Venus is actually called our sister planet, but it's so hot that it actually can't support life. So the thickness of our atmosphere is really important because it allows for us to cycle things such as water, carbon, phosphorus, nitrogen, those are, and oxygen, those are all things that are being cycled through our atmosphere, which allow us to maintain life. We know in our early atmosphere we had a lot of pneumonia, methane, water vapor, and carbon dioxide, and just a small amount of oxygen. We didn't have a lot of oxygen, almost no oxygen. Oxygen actually was produced by what we call as cyanobacteria, and they put oxygen into our atmosphere. And that was about 3.5 billion years ago. Now, we know that the water that we have came from comets striking our surface. So 4.5 billion years ago, when our planet first started, it was this crazy mess. And now we've kind of calmed down. We've aged quite a bit, our planet has. And we are starting to see that we have these cycles occur. Things do change, but for the most part, we have our atmosphere, we have our cycles, we have our oceans now, and those are all necessary to move on to the next stage, which is the formation of life. And so tomorrow you'll watch a video, and please do note that you do have questions that you need to answer, and they will be due on Wednesday.